to Coding Project Depth. Today we are building our Reptile cursor animation using JavaScript and HTML canvas. Each features is added step by step, so it's easy to follow along. Let's get started. First of all, we create our folder named Reptile cursor on desktop, and then we will open this with Visual Studio Code. After that, next we will add two files, index.html and another file is script.js, and start building our project. We start with a simple things, so we already create these two files. So now we start in index.html by typing exclamation mark, and it will give this pre-ready-made code. And now we'll change this title to Coding Project Dev, and inside this body we will add h1 tag. So for tutorial for Reptile cursor, and we'll also add script.js inside this body of index.html file, and then we go to live server, and we'll locally run this project in our local browser. So yeah, our project is running smoothly. This script.js is the main part of our project, so this script.js file is empty for now. We'll use it to create the canvas, drag the mouse, handle resizing, and build the lizard's head, body, and movement, adding everything step by step, so it's easy to follow. So let's get started coding in this script.js. First we'll create a canvas. We'll use create element canvas. This line creates a new canvas, and after that we will add admin child. This line adds the canvas to the page so it becomes visible and usable. Next we will use basic styling, so set margin 0 for the canvas, and for overflow we'll use hidden, and for the background color we use this RGB6810, so it will set a dark background. Next we'll get context. This line gets the 2D drawing context from the canvas, which let us draw shape and animation, and we use line width 2. After that we resize the canvas to always fit the screen, so we'll get the function resize canvas with window inner width, and for height we use a canvas dot height, window dot inner height, and then resize canvas, window dot add event listener. Let's resize this, and after that resize canvas. Then we will use main loop just to make a int for now. Finally we start an animation loop that clear the canvas and prepares it for animation. Canvas dot height request animation frame. So and finally we do the animation loop. So this code create a full responsive full screen canvas and run a continuous loop animation. So yeah, and we'll test it. Yeah, now set our background as this dark color. So yeah, and we'll stop it and go live again, and yeah, it's perfectly working, right? So it's full responsive, and we'll remove this S1 tab for now, and then we gonna look here. It's gone. So let's get back to our code, script.js, and before this create canvas, we'll add the base color value which control the reptile's head color. So we'll use u base 232. This will set the light purple and blue. Next we'll add some color helpers for the head. For this we use const head hue equals to u base plus 360, and we'll creature head only for now, and we'll create a class creature constructor xy equals to 0, and this data x equal to x, this y equals to y, and this abs angle equals to angle, and I will draw const r equal to 4, and we'll begin the part. Inside the draw method, we use canvas arcs and the lines to draw a rounded head shape with a pointed face, creating a reptile-like look. This is the head hue, and it sets the color also. This that x, this that y, r, and we'll use some mat pi divided for this angle, and 7 times mat pi divided by 4 this abs angle, and we'll add some face wedge, cts dot move to, and then this x plus r mat const 7 times mat pi divided by 4, and for y-axis we use mat sine 7 times mat pi divided 4. After this move to, we'll cts dot move line 2, this dot x, we'll add some mat here, and for y also do the same. And after this we do ctx dot line 2, do the similar things, and this dot x mat dot con cos mat dot pi divided 4, and for y also do the same, mat dot sine mat dot pi divided 4. After this we'll close the part, ctx dot close part, and ctx dot fill, ctx dot stroke. After that we'll let critter, we'll spawn the head in the center, so there is no movement for now, and we'll use function start head, resize the canvas, and critter equal to new creature, window that we enter width divided by 2, and for height we'll use same, and we'll start the head. So we need to spawn the head at the center of the screen and keep it stationary for now. So we already draw the head, so we'll remove this empty for now and set it for This code draws a colored reptile head at the center of the screen using canvas and continuously renders it in an animation loop. So yeah, and we will do a live again, and yeah, you see this head is coming in the center of the canvas. So this is the head for now. So next we'll add some mouse position by listening mouse movement and storing the cursor x and y coordinates, and we'll add some movement tracking here. So we'll add mouse input tracking. We'll use input x 0 y 0, and document will add event listener mouse movement, and we'll use add function input x inclined x and input y inclined y, and we'll close this. So before that we have just creature with no head only. Now we'll add movement also. Now we will add some drawn movement values for the head for simple smooth. We'll some add movement value, this dot speed and this dot acceleration and this dot friction. Next we'll use this dot max speed, and next this dot drawn speed, and next drawn acceleration, and lastly we'll add this dot drawn friction. So next we'll follow dx and dy, and we'll add dx and dy, which measures the distance from the creature to the cursor. So distance calculate how far away the cursor is, and this will tells the creature where the cursor is. So we'll add the desired angle towards the cursor, and we'll use some math here, and after that we'll add certain angle distance. This will let the target angle, and if -2 with some math 4, and after that we'll draw the cursor, and we also add some speed and acceleration and friction, all the angle things we're gonna add here, and after that we'll accelerate the cursor if it is too close or not. So for this we use if this speed equals to this acceleration and this speed equals to math minimum max speed, and this speed minus this friction, and after that we move forward in facing direction. We'll add some math cos and sine. Now next we remove the center spawn function and directly create the creature at the center using a single line of code. Where creator equal to new creature, we'll use inner width divided by 2 and inner width height divided by 2, 0. Now in main loop we'll change from draw head only to head follow cursor, and then follow, which will get input x and input y, and it will request the animation loop for the reptile cursor. Now we'll go live here, and yeah, now this reptile head is following our cursor, and it's following wherever we move our cursor. So this is the main part of the mouse tracking system, where it get x and y client, and it will take input. Now after this line we'll add const leg num equal to 6. This will fix number of legs, and then after this we'll add tail length equal to 25. This will fix the length of tail. After this we'll change some on this color helpers. This is for tail and num, so we'll change some here to get the perfect color. So let's segment count first equal to 0, and then const hue weight equal to hue space. We'll hue weight equal to, we'll keep this number, and after that we'll get the class segment. It will get parent, size, angle, range, stiffness, segment count plus plus, and this segment true. This parent equals to parent, parent children was this, and this children, and also size, and then this is the length of the segment, and we'll get angle related to parent, and we'll get the default angle. Also we'll get parent absolute whole angle. Also we'll get the range. This will allowable swing range, and we'll also get the stiffness. This will the angle stiffness for damping, and after that we'll get the color narrow, muted saturation lightness. We'll get some color here, 1.2 360, and we'll get this lightly purple color, and we update our relatives true false, and after that we'll keep relative angle within range, and update position, update relative into flex, and normalize angle around default. We'll add some mathematics, and after this we'll apply stiffness bound flexing. If flex, we'll get a relative angle, relative angle plus this range divided by 2. Also relative angle minus this range divided by 2. Relative angle plus this angle, and we'll close this. And after that we'll update absolute angle and position. We'll add some this parent absolute angle, and we'll add some for x and y. If either these children for is followed by arrow, draw it here, and next stroke, this stroke will also get begin part, and move to this parent x to y, and line to this x to this y, and enter this children for each, draw true. Then follow inverse kinetics style for chain children. We'll follow it here, and we'll add this just like before. Acceleration, friction, trace, acceleration, friction, or trace, and we'll change this after this angle. We'll add forward motion pattern. We'll get speed, acceleration, and friction, and this, and after this we'll add some rotational motion parameter. Speed, we'll add speed, acceleration, and friction, just like motion. And after this rotational motion param, will get a children segment and limbs system. This children equals to this, and this system is equal to this, and after this we'll move target cursor with friction resistance, followed by x comma y this mat height mode, this x minus x, y minus y, and we'll get also at this one, this x, and after this we'll get forward acceleration scale by leg grounding. Let acceleration, this f acceleration, if this system length is greater than 0, let grounded equals to 0. This system for each grounded step equal to 0. Acceleration grounded this system length, and close this, and this speed, acceleration, distance greater by this frame, and we'll add mat.max, and after this we'll rotational control toward cursor. This will rotate towards cursor. Let diff equals to this absolute angle minus angle. Now next we remove from line 150 to this line 170, because this movement logic works well for a simple head falling animation. However, we remove it because it's too basic for a full lizard with a body, tail, and leg. We will replace it later for more advanced system that separates forward motion and rotation. And also we remove from 151 to 161 for now, and replace with this matte function. By replacing this, will smooth control rotation toward the cursor. It turns only when the angle difference and distance are large enough. Applies acceleration to rotate the correct direction, then use resistance and friction to slow and stop the rotation and keeping the movement speed equal this friction and this speed, else this speed equals to 0. Next we'll integrate position plus angle, and this will update the creature rotation and position. First it applies the current rotational speed to update the angle and normalize the angle so it stays within a valid range. After that it moves to the creature tool by updating its x and y position. Next we'll update children and legs in a head forward frame, and we'll use absolute angle by and its children for each followed by arrow true, and for each update we'll update x and y, and after that we'll draw this true. And we'll add iter inside this bracket. Next we will remove this close part and add if statement. If iter this children for each followed by row true, make it true. And after this next we will remove let creature because it creates only simple creature at the center of the screen. As the project grows, we need a more advanced setup that beautiful lizard structure, head, body, tail. So we'll add this, add the new creature followed by inner width and inner height divided by 2. Also we will add forward acceleration. After that we will add forward friction 1.8, and after that we will forward resistance 0.4. We'll also add threshold forward by 12, and rotational acceleration we also add head and body followed by cursor. So here we'll add base size, scale of the creature based on the number of legs, and we'll add greeter that will store lizard, and animation ID is used for the animation loop, and we'll also add the window width and window height, and return base size. Start lizard. If animate ID, that will cancel animation frame. Animation ID segment counts will 0, and after that we'll resize the canvas, and creator will lizard, it's on complete scale, tail length, and tick. Change this loop to tick, and we'll remove this too, and add animation ID. For that, animation ID equals to request animation frame, tick. After that, we'll remove this loop so that our window will resize the lizard. So window dot add event listener resize restart lizard, and restart lizard. This will start lizard. After this, we'll go live here, and now our lizard is spinning very fast, and also the body is thin, very thin, so we need to change some to make bigger and make a smooth movement. So now we'll change this line number 43. We'll change this by FXL. By this, and after this we will remove this X and Y 117, and after that so this short bracket font will just make it neck for now, and we'll add draw suspend here, that will increase the thickness of body. So for that, let I equals to 0 body pairs, and so add spinal equals to new segment. So let node equals to new segment. So this will make the body thickness more than before. Now we'll add after this complete scale, we'll add leg knob of the lizard. Then we'll go live again to run the project. Oh, it's blank. No need to worry, we'll go inspect and we'll figure out what's wrong with the code. So let's go to console. Oh yeah, we have a problem in build lizard, right? So we need to yeah, here in build lizard we missed this body pierce. We'll change this, and yeah, and after that we'll remove some code, this forward acceleration for now. Let's remove it. Okay, now we'll test it again. So yeah, now it's working smoothly, and it's more way bigger than before, so this one is good. So next we'll add, so now we'll need to make a limb system also for the lizard, so that will handle node chains reaching a point. So we'll class limb system, length is between creature, and we'll end, and this length, this will be normal node, and length, and creature equals to creature, and we'll add speed equals to speed. We'll also use the capture system to push this, and this node, let node equals to end, and after that we'll collect out the chain, and for let, for that let I equals to 0, and this node on shift, and node equals to node apparent, and if node is segment we'll break this, and this heap equals to this node, this will root join the heap, and we'll move limbs to the target, so basic, move to XY, and update first for the relative angles, and let this equals to mat high both, and for X and Y, and then let max this speed. So we'll after that we'll traverse from backward enforcing length. So further let I equals to this node length, and const node equals to this node I set this bracket, and const angle will add mat for X and Y, and we'll use node X equals to X length for cos sine angle, and for Y also we'll use sine angle, and yeah, after this we'll recompute angles for node. We'll recompute angles for node. This node for each node followed by arrow, will absolute angle equals to mat median 2 for node Y and node parent Y, node X and node parent X. After this we'll update children not in length chain. So node children for each child equals to if this node includes child, this will update relative to comma false closed, and update this move to input X and Y, that will followed by cursor, and leg system will add the stepping logic. We'll add class leg system constructor, will use int length speed and creature, and super int length speed creature. So for int X and Y, doing step equals to 0, and forwardness will set that one is also 0, so step equals to 0, and we'll add some math, and after this we'll compute swing orientation, const relative angle, let this creature absolute angle, if this step equals to 0, then if for the initiate step const list equals to net hyper for x and y, and if this is greater than 1, step 1 is called if x, and yeah, we'll do for both x and y. Else if this step equals to 1, while swinging loop for settling condition, we'll use theta for both int and single, and for const forwardness 2 equals to this times mat cos theta, const df this forwardness minus forwardness 2, so this forwardness equal to forwardness 2. If df times df less than 1, then we'll plant root foot. So this step 0 will set this goal x, heap x, index and heap x for both x and y. And we'll close this. Now here we'll adjust the forward acceleration based on how many legs are touching the ground. If more legs are planted, the lizard moves stronger and more stable. If fewer legs are grounded, it slows down, make the movement feels more realistic. So change this to SL. This will make movement more smooth. So after this for each follow, we'll add for each update for x and y. So now in lizard assembly, we'll update legs, tail and body thickness, so that we already built our lizard body, tail and legs, so it will update it. And in this tour pane, we'll add leg anchors. And let's change this body pierce to a leg, so it will keep the lizard leg. And if I is greater than 0, then it will keep this leg. And after this we'll add leg pair for leg. This one leg node equals to new segment spinal. We'll add this mat, and also leg node new segment spinal. We add the same for upper and mid, and for this one is for the lower leg. that completes our lizard cursor project. We built a full screen canvas, dragged the mouse, and step added smooth movement body segment, a flexible tail, and realistic leg animation. This result is a responsive, natural looking lizard that follows the cursor in the real time. So yeah, this is the project that we just completed. It's working very nice. So let's look it by side. That's cool, right? It's following perfectly that cursor. So we'll change some speed for the laser here. So here is for our acceleration is 12, so we'll make it 5. Now take a look. Now it's a little bit slower than before. And whatever you guys need to make the changes of the lizard, like acceleration, friction, resistance, threshold, something like that. You change it from this function build lizard. If you enjoyed this project, please don't forget to like the video, subscribe to Coding Project Day, and comment if you would like to see more